Lesson 1, Rutherford scattering. This is the beginning of a new topic, radiation. Radiation isn't that difficult, to be honest. It combines a lot of things we've already looked at. We've done a lot of QM before, we've done alpha, beta, and gamma radiation before, we've done a lot of that kind of thing. What this topic's going to do is it's going to bring together a lot of those ideas, formalize them, and on some just go a bit deeper. Also, in the back half of this topic, we're going to be looking at the workings of a nuclear power plant. We're going to be doing some engineering and practical physics. Can you imagine? So, first thing that we need to know about is Rutherford scattering. The story of Rutherford scattering goes like this. Just down the road here in Manchester, at the physics lab, a group of scientists were firing electrons at an incredibly thin bit of gold leaf. They had the gold leaf set up here, and they were firing electrons at it to a detector on the other side. And they were seeing how many electrons got through to the detector. Now they actually had a detector set up on the side that they were firing from as well. The story goes that they asked an intern to check if any pings were coming on this detector as a sort of joke. So they sent him off for 4 hours, and he came back and he said, here are the pings that I have found. Some of the electrons have bounced off this gold leaf, come back and hit this detector. And this was astonishing. No one was expecting it. They'd just done it as a practical joke because they didn't like the guy. But Rutherford realized what this meant. So, what's going on? Well, it turns out that when you fire electrons through a very thin sheet of gold leaf, almost all of them pass straight through without deviating at all. It's as though they just went through air. The gold leaf is invisible to them. Now, the reason for this, what this tells us, is that most of an atom is empty space. There's a nucleus in the middle and huge amounts of space around it, meaning the majority of the electrons just pass straight through. So this is the first thing you need to know for your exam. Almost all electrons pass straight through, which tells us most of the atom is empty space. However, a small number of electrons got very close to the nucleus and were repelled backwards at massive angles. They didn't just bend a little bit, they flew straight back or flew right up or right down. Huge deviations. So this tells us that there must be a lot of charge in the nucleus, and also that this charge must be such to repel these electrons. So, two things that we learn. One, most of the atom empty, therefore the electrons fly straight through. Two, a lot of charge in the middle, therefore some electrons get big, big deflections. There's a few difficult questions that they often ask about this in the exam, mainly about how close an electron's going to get before it bends, or how much it will bend. In order to answer these questions, think about energy moving over time, or an integral of the force, if you will, because of course if we integrate force over distance, we'll get an energy. And then you can work out the answers. There's a couple of those to practice this week. I'll see you later in the week.